some reason. Okay, now we're recording. Okay, we're doing lab experiment number 10, which is a loaded voltage divider. And the first thing we're going to do is build figure 10.2, which we have built. And what we're going to do is we're going to measure the current through the second resistor, and because of the way we have our current meter hooked up, that's going to be 497 milliamps. And then we're going to measure the voltage across R2, and that's the no-load voltage of the circuit, and we have 4.97 volts, which we'd expect because we have two 10K resistors and 10 volts going across them. Okay, we're now going to go and add a load resistor, and because we want to know the current through the load, we're going to put a current meter in so we can measure that current. Okay, so now we see that at 10K we have 47 milliamps as our load resistance. We need to know the current 2, which would be 522 milliamps minus that 47 milliamps. So we don't necessarily have to measure it. We can do a subtraction there. And then we need to find the voltage across the load resistor. So now we're going to hook up a voltmeter, measure the voltage across the load resistor, and we get 4.71 volts. Okay, now we're going to do it again. We're going to replace the load resistor with 47K. Okay, so now we're at 47K. We find that our current through the load resistor has gone up. It's 96 milliamps. We have 544 milliamps through the total circuit. From that we can calculate I1, and now we're going to measure the voltage across the load resistance, and we get a number of 4.45 volts. We're going to do it again with a 1K resistor. Okay, now our current through the load, 814 milliamps. Okay, and our voltage across the load, 8.1 volts. So the voltage has gone down considerably. We're now going to replace it with a 100 ohm resistor. Nope. And we see 9.53 milliamps through the load resistor, 974 milliamps total. And now we're going to go and measure the voltage across the resistor, and we find that it is all of 0.1 volts, which isn't a whole heck of a lot. All right, now we're going to do it again, but this time we're going to replace our two resistors that used to be 10K. We're going to replace them with 1K resistors. Okay, now with 1K resistors, that'd be 2K total. We see 4.98 milliamps, and we have 10 volts. 10 volts divided by 1K, well in this case 2K, and so the math is right. And now we're going to put in a 100K ohm resistor as our load in the circuit. And when we do that, we see we have a current of 49 milliamps and a total current of, actually that's not 49 milliamps, that's 49 microamps. And we have a total of 4.03 milliamps total. Now we're going to measure the voltage across the load resistor. And we see our voltage is 4.97 volts. Okay, we're going to put in a 4.K ohm resistor into the circuit. Okay, and with a 47K ohm resistor, we see we have 105 microamps flowing through the load and 5.07 milliamps flowing through the circuit, and the voltage across the load resistor 4.87. Okay, now we're going to go and put in a 1K resistor. And now we're challenging. Okay, so now we're seeing 3.32 milliamps with a total resistor, total current of 6.73, and the voltage across is going to be 3.26 volts. Okay, one more time with a 100 ohm resistor. Okay, we're getting 8.2 milliamps across the 100 ohm resistor with 9 milliamps total. The voltage across the 100 ohm resistor reads 0.89 volts. Okay, turn the page. Remove the power supply, remove something else. We're going to do the same thing over again, except this time we're going to do it and we're going to vary the resistor R1. And I think that that's good enough. I don't think we need to do any more, do you? No. Okay. So that ends our presentation of exercise number 10. Before we sign off, I'm pretty sure that I was reading the currents wrong. When we had the 10K ohm guys, I was saying milliamps when in fact we had microamps in those circuits. So the disclaimer there, I may have done something wrong. All right?